We can determine the pH of a salt solution qualitatively by considering which acid and which base would have reacted together to make that salt. So first, take your salt and split it into the cation and anion components. Then, with the anion, add a hydrogen to make it into the acid that reacted to form the salt, and then take the cation and remove a hydrogen to make it into the base that formed the salt. Sometimes you'll have a cation that doesn't have a hydrogen to remove. In that case, instead add OH to the cation. Then, once you have your acid and base that reacted together to make the salt, consider the strength of those acids and bases. If you have a strong acid and a strong base that reacted together, then the salt that they form would be neutral. If you have a strong acid with a weak base, then the salt will be acidic, whereas if you have a weak acid with a strong base, the salt will be basic. So let's look at a couple of examples. First, we have NaCl. I'll start by splitting it into the cation component, which is Na+, and the anion component, which is Cl-. Next, I need to add a hydrogen to the anion to make the acid that reacted, so that would be HCl. And I need to remove a hydrogen from the cation, but there isn't one, so instead I'm going to do this lower step, which is adding OH. So it came from the base NaOH. Now I need to classify these as either strong or weak. So NaOH is a strong base and HCl is a strong acid. So when they react together, they make a neutral salt, meaning that at 298 Kelvin, I'd expect the pH of an NaCl solution to be equal to 7, so neutral. Now consider another example. So for example, CH3COONA. I'm going to do the same thing, which is that I'm going to split them into the cation and anion components. So first I have CH3COO-, and then I have Na+. For the anion, we add a hydrogen to make it into the acid that reacted, so that's CH3COOH. And for the cation, we remove a hydrogen, but there isn't one to remove here, so again, I add OH. So we have NaOH. CH3COOH is a weak acid, and NaOH is a strong base, so when they react together, since it's the base that's strong, they make a basic salt. And so if we have a solution of this CH3COONA, we would expect it to have a pH of greater than 7. It would be a basic solution. In this example here, I can split into the cation NH4+ and the anion NO3-. With the cation, I will now remove a hydrogen to make it into the base that reacted, and with the anion, I will add a hydrogen to make it into the acid that reacted. NH3 is a weak base and HNO3 is a strong acid, so since it is the acid that is strong, these will react together to make an acidic salt. So if we have a solution of NH4NO3, our acidic salt, it will have a pH of less than 7 at 298 Kelvin.